Hi, and welcome to the calibration video of the LumenPnP setup video series. If you have not yet set up OpenPnP and imported your configuration files, you can click on the link right here to go to the first video in this series, and then you can come back to this one. All right, so first, a couple really important notes about calibration before we dive in. The order of steps in the docs is in a very specific order. We have them in this order because some of these steps actually depend on each other, so it's really important we do them in this order. Also, as you're going through this video, make sure you are constantly referencing the written docs, as they are always the most up-to-date version of the documentation. All right, first thing, we are going to connect to the machine. So at the end of the last video, we opened up OpenPnP with our configuration files, but we have not yet actually connected to our machine. So first thing we're going to do is we're going to close OpenPnP. This is because of the way that OpenPnP handles discovering new USB devices. It has a hard time finding new devices when they've been plugged in after it's already been opened. So we're going to plug everything in first, and then we're going to open up OpenPnP. First things first, I'm going to plug in the barrel jack into my LumenPnP. We always do this first because it ensures a proper boot order for the processor on the LumenPnP motherboard. So you can plug in your barrel jack, and you should see the ring lights on your machine go through an RGB color cycle. That means that Marlon has booted up and it's ready to go. Next, you can plug the USB port from your computer into your LumenPnP. This is a USB type B plug. And then lastly, we're going to plug in both of our cameras. The ports that you select for your cameras are very important. Your computer has built-in USB hubs inside of it, and in order to properly handle all of this data that we're sending of these two camera feeds that we're sending over USB, it's always better to put them on two separate USB hubs, which typically means you're plugging them into different sides of your computer. I'll plug in the top camera on one side and the bottom camera on the other, hopefully getting two different hardware USB hubs inside my computer and helping with throughput of the data. All right, and now I have both my cameras plugged in, my Lumen is powered on and also plugged in. It's time to open OpenPnP. And for all of these steps, we have warnings on the docs page about doing things in this order, just to make sure things are very consistent. So the very first thing we're going to do is we're going to make sure we can talk to your LumenPnP by configuring the serial port for the machine. So first we're going to go to the machine setup tab. This tab in OpenPnP is where pretty much all of your settings and calibration happens. It's all in this nested directory structure, which can be kind of hard to find stuff sometimes. It can be handy to click this little expand checkbox, which will open up literally everything. You may not want everything. I usually will minimize axes because we don't really have to mess with that. But then that opens up mostly everything else you might need to interface with. In general, when you click on a row, it will bring up the settings for that item that you've selected in the pane on the bottom. So this is my N1, it's the left nozzle on the machine, and here's a bunch of settings for that nozzle. But for serial port, we're going to scroll down under drivers to G-code driver, G-code driver, and we're going to click on that. And then under configuration, you'll see there's a serial port section that has port. Now, by default, it has this TTY USB modem and then a bunch of numbers and letters. This is just the port that comes with the configuration by default. But what we're going to do is we're going to click this drop down and we're going to look for a different port. Now, on Linux, it's going to be something like TTY ACM. So this is our port here. The S4 and S0, that's not for us. And even though there actually isn't a TTY USB modem port connected right now, OpenPnP still shows it to you, which can be kind of confusing. So we're just going to select the ACM0. If you're on Windows, the port will look something like COM1 or COM2 or COM some integer. And on Mac, it will be in the format of TTY or CU.USB modem and then a bunch of other numbers. Great, so now that we've selected our port, I'm going to hit the apply button in the bottom right. This is super important for OpenPnP. Let me move myself out of the way here so you can see. I'm going to hit this apply button down here. A lot of information does not get saved if you do not hit this, so always check for when you're updating a setting in OpenPnP that you go and you click the apply button. So I'm going to hit apply here, and now OpenPnP knows that's my port, and I'm going to try and connect to it. I'm going to use the little power button here in the bottom left. We're going to click it, and we're going to see what happens. All right, so now we get all of our jog buttons light up. Our power button turns red and the home is yellow. That means we have connected to our machine and it's not homed yet. Yellow means machine not homed, you can see in the pop-up. So this is great. This was our port. We're connected. We had communication with the machine. We're ready to go. The way that we're going to double check this is by turning on the ring lights for the machine. We're also going to need this for a later step of configuring our cameras, so it works out well. Go to the actuators tab on the left side, and then under here you'll find LED, photon feeder data, VAC1 and VAC2. We're going to click on LED and it's going to bring up a little window where I can set a Boolean value. So if I hit on, the ring lights will come on, and then off, of course, we'll turn them off as well. So this is a way that you can manually control some features of the machine. Similar to the VAC1 and VAC2, I can also select these and turn on the vacuum line for the left nozzle, and then VAC2 is for the right nozzle. Same thing. Photon feeder data is just used by talking to feeders, and it's nothing we ever interact with directly. Great, so now that our LEDs are on, we're going to configure our bottom camera settings. When you're in OpenPnP and you see this big red X over the viewfinder, that means it's not actually pulling in a video feed, it's not configured yet. So in order to do that, we're going to go to our machine setup tab, and we're going to go to cameras, and then OpenPnP capture camera bottom. Now confusingly, the top camera is actually under heads, reference head, cameras, and then the camera object exists in there because that camera is part of the head. The cameras are not together. So for the bottom camera, it's just its own separate field. So just go look for the cameras drop down and then click on capture camera bottom. Once you have that selected, you can click on the device settings tab in the bottom pane. And then we're gonna select our device. So if I click this drop down here, we can see we have PNP top camera and PNP bottom camera. So we're gonna select bottom camera. On Windows and sometimes on Mac, depending on how the cameras enumerate and how OpenPnP chooses to handle them, the names of these cameras can actually be flipped around, or sometimes they'll duplicate the name. If you select this and you realize that it's actually the wrong camera, it's pretty easy to just go and select the other one and then resave it, and it works just fine. But just something to be aware of, if you see different or weird naming in there, it's probably, especially if you're on Windows, it's a bug with how Windows handles things enumerating with OpenPnP. So just go ahead and select the other camera. For format, we're going to pick the highest resolution at the lowest frame rate. Generally, this means 1280 by 720 at 10 FPS. So I'm going to click my drop down here. You can see there's a lot of options. I'm going to select the 1280 by 720 here at 10 FPS. I don't need a lot of frames, but I want a nice, crisp image, the best one I can get from the camera. So I'm going to click that. I'm not going to hit the test capture FPS button. OpenPnP tries to run this whole test. We've had a hard time with this setting in the past, so we don't recommend using it. And then once you have all this set up, you can go ahead and hit apply. Great, and you can see immediately that X goes away, and now we just have a black field for our camera over here. If you are not seeing these camera feeds over on the left side, you can go to your little drop down underneath cameras and select show all horizontal. You can do vertical as well, but it just fits the UI a little bit better if you do show all horizontal, so you can see what's going on a little better. So if the red X has gone away in this window, it means we are pulling in a feed. It's probably just that we either still have the lens cap on or the exposure is too low. So this is a good sign. It's all good, even though it looks really dark, that's fine. Do check to see if your lens cap is still on though. I've forgotten that a good number of times. But so that we can use it for a little bit of navigation and making sure it's working properly, we do want to adjust the exposure so we can see something. Here, still in the device settings tab under your camera, you can see that there's a few sliders that you can adjust, and some have a little checkbox with auto next to it. Exposure has an auto checkbox. Turning this on will turn on auto exposure, and it will automatically try and figure out what exposure lets you see what's going on. You can also just slide the slider to adjust it. But when you're just trying to see what's going on, I'll just select the auto exposure, and you can see when I do this, it will start to set the exposure based on what it thinks I want to see. So I'm now going to uncheck this because I don't want it to be constantly changing as I'm doing things. And you can also see by dragging the slider along, I can manually change the exposure of the bottom camera, which we're going to be fine-tuning a little bit later. But you can see if I hold my hand over the bottom camera, sure enough, there's my hand wiggling over there. Awesome, that's great. All right, and now we're gonna do the exact same thing for the top camera. Get it connected and just get it so that we can see what the heck is going on. So I'm gonna scroll up to my heads list, reference head, and then underneath the cameras drop down, there is a top camera. It's gonna look effectively the same as your bottom camera. Under device, you're gonna select PNP top camera. Same thing for the format, 1280 by 720 at 10 FPS, highest resolution, lowest frame rate. And we're gonna hit apply, and it's gonna think for a second, and we should see our red X go away. And there we go, we're connected, we have the feed coming in, and I'm gonna check auto exposure, bring up some exposure on my top camera, and then uncheck it. And now we have a static exposure, and there's our feed of my hand wiggling in the way right there. So great, we now have both cameras connected, exposure adjusted, not quite tweaked yet, but enough that we can see what's going on. The next step is setting up the homing fiducials. So in the LumenPnP homes, it moves to the front left corner of the machine, but that homing is not precise enough for accurate placement. So what we do is we actually jog to go find a little dot on this datum board, which is right above your bottom camera, and we use that dot to actually determine the home position for the machine. This is the central part of every part of calibration from here on out. Everything relies on this, so this is why this is the very first actual calibration step that we do. To start off, we're going to home the machine. It's really important to make sure that both of your nozzles are level when you're doing this. OpenPnP does not know how to check to see if your heads are level. So before you hit home in OpenPnP, make sure you can just manually adjust them to make sure that your heads are about the same height. Now in OpenPnP, I'm going to go to my jog tab and I'm going to hit home, and we're going to see what happens. So the Lumen moves to the front left corner and home Z, and then it stays there. This is because we haven't enabled the fiducial homing yet, but that's exactly what we're about to do. If your machine does not move all the way to the front left when this step happens, it's probably because you need to tune your sensorless homing settings. There's a link in the description for the instructions about how to go about doing that. And there's also a section of a video right here where we walk through that process as well. So now we're going to tell LumenPnP where our homing fiducial is. The way we're going to do this is by going into reference head H1. And in here, this is the information about where the homing fiducial is stored. It's kind of in an interesting spot. But what we're going to do is you can see homing method is set to none. We're actually going to change this to reset to fiducial location. And this is going to let us start editing some of these values here. So I'm going to hit apply in the bottom right, like we always do when we make changes. And you can see there's already a position in here, an X and Y position for our homing fiducial. This is the one that we've set here to be approximately where it's going to be on your machine, but every machine is assembled just a little bit different, and it's really important we get this very accurate. So we're going to set it just a little bit more precisely. This also brings up a really important thing that you'll see all the way across OpenPnP, which are these little buttons that you'll find next to data fields pretty frequently. These fields will either move to or capture a position in or out of these fields, these data fields that they're next to. So for example, this button, which has the blue circle in the middle and the red bracketed outline, this will move the camera to the position in the fields next door. So pressing this button will jog the head to these coordinate points. The blue version of this will actually take the current position the camera's on and save it into that data field. This can be a little confusing, and sometimes clicking on the save data field will completely overwrite what's in that field and forces you to go redo it. So it's really important to make sure you're clicking on the right one when you're trying to jog to a position or capture a position. And the same thing goes for the nozzle too. This is the jog nozzle to position button, and this also includes a Z value as well. So you really need to be careful when you're clicking these buttons because the head's just going to move straight to that Z position. And capturing where the nozzle tip position is. Solid blue is always capture, a little bit of red means move to. So what I'm going to do first is I'm going to click the move camera to position button, and we're going to see how close my machine's homing fiducial was to the default configuration. All right, so here we are. We've jogged to the position, and we can see already our exposure is pretty high on the top camera. It's kind of hard to see what's going on. So I'm going to go back to my top camera, and I'm just going to adjust my exposure down a little bit. I had set it with auto exposure, so now I'm going to manually set it by moving my slider. And there, it's a little bit easier to see. This is actually pretty dead on for about where we want it to be. So now I'm going to go back to my reference head H1, and I'm actually just going to jog so that my center of my view is directly centered over the homing fiducial. That's this dot inside the Opula logo. What can be really handy when you're doing this is if you right-click in the center of your field of view, you can change what's called your reticle, which is what's overlaid on the vision so that you can see what your center point is. We recommend using crosshair, but there's a lot of other different options that will overlay different things on top of your view to help with alignment. Now I can go down into my jog tab here in the bottom left, and I can adjust my distance to be a small distance and then jog in X and Y. So every time I click this arrow button, it's going to jog the distance I have selected here. So right here, this is 100 microns. This is 0.1 millimeters. So if I jog up, the machine's going to jog up just a little bit. I can even go all the way down to 10 microns. Really, really, really fine movement. And I can adjust like this and jog it in place. Or you can actually click on the camera view, and wherever your cursor is when you let go, the camera will jog to that position. So I can actually jog to that position just by clicking on it in the field of view, which is pretty cool. So I'm going to jog to the center of the dot, maybe a little bit finer adjustment here. And this is my homing fiducial position. This is what I want OpenPnP to remember. This is where it should jog to go look for this fiducial whenever I home again. So now what I'm going to do is I'm going to take this position and I'm going to capture it and save it into this field with the blue button right here. So I'm going to click this, capture the position, and now you can see it has saved my current position into these fields. And we're actually going to do the same thing down here for primary fiducial, but I'm just going to capture this position as well with my camera. Same position. I want homing fiducial and primary fiducial to have the same information in them. This is the only time you should ever do this and save this data in here. If you set up a bunch of feeder positions and board positions and a whole bunch of other calibration data, changing this homing fiducial position is going to shift everything. So you should only ever set this position once. All right, now we're gonna hit apply to save this data. Now before we try and home and see if we can do a fiducial homing, we need to make sure our exposure looks good. So when the camera tries to figure out where this central dot is, this homing fiducial, we want it to have a good chance of finding it. The way we're gonna do this is really just by adjusting the exposure. That's the main variable you have to adjust to make sure that the camera can find things well. A handy tool that you can use when going through this process is by right-clicking on the view and then clicking on Show Image Info. And this will bring up a little histogram of the view from the camera feed. This means that it's actually showing you on the left side are dark pixels, the right side is light pixels, and the height of the peak is how many pixels of that brightness there are. So you can see there's a really, really tall peak of pure white. not a lot in the pretty bright, and then it starts to pick up in this kind of lower gray area. So now I'm going to go back to my top camera, and I'm going to adjust my exposure. The trick here is I want to have a really good separation between that peak and the bottom end. So you can see here I have a nice peak way at the top end, pure white, and then I have a bump down at the bottom. This is pretty much what you're looking for your histogram. And this means that the camera is going to have a really easy time finding this circle. Because of how OpenPnP handles communication with the cameras, it can forget what your exposure settings are and does not necessarily send them to your camera on boot. So you might need to set this every time you turn on OpenPnP and reconnect to your machine. For this reason, we recommend leaving your machine connected to OpenPnP so it just has all that configuration live and still running, and only turn off when you absolutely have to. But if you do need to do it, just take note of this exposure number. I currently have mine set at 178, so I'll just remember this for the next time I boot up for this machine. And so now we're going to try Fiducial homing. We have changed the homing method to reset to Fiducial location, so when we home, it'll do what it normally does and move to the front left and do its mechanical homing, but then it'll try to find the homing Fiducial. So let's see what happens. I'm gonna hit the home button. It's gonna move the front left, and then go find the Fiducial. So there you can see it found the Fiducial. It's putting the little green crosshair perfectly on it, and it leaves the machine perfectly centered on the Fiducial. That's perfect. That's exactly what we want to see. You can see the first time it went to go find it, it actually wasn't perfectly centered on it. That's totally okay. There's a little bit of variation in homing for the actual XY position that it reports every time. So you will see a slight variation in where it goes to find the homing Fiducial, but that's exactly why we have this step, so that we can calibrate out that slight difference in mechanical homing and we always return to the exact same position. If OpenPnP did not find the homing Fiducial well and it did not center perfectly in the center of this logo like this, that's all right. It just means that we need to tune the pipeline just a little bit or change your exposure. There is a separate video about doing this exact thing, which we have linked in the description. All right, our next calibration step is a millimeters per pixel calibration. This is a super important calibration in OpenPnP that tells it how many pixels are in a millimeter. This is super important for when it's doing vision alignment, knowing how far to move to correct for any offsets. We actually do have a default pixels per millimeter calibration that is totally fine out of the gate, but it cannot hurt to do it again just to be sure, and we also do a couple other steps in the process, so it works out pretty well. The very first thing we're going to do is mount nozzle tips onto our nozzles. A super important thing to do here is to lubricate the nozzles so that the nozzle tips slide on very easily. We do this here at Opula before we send out every machine. Try and slide it on. It should go on pretty easily. We include a little packet of super lube for doing exactly this, so can't hurt to give it a little bit extra. And then go ahead and remove the N045 and the N24 nozzle tips from your nozzle tip rack. I've got mine right here. These two nozzle tips will pick pretty much any part that you need to place on your lumen. The N045 is the smallest one, so it works really well with passives and goes all the way down to 0402. And then the N24 is big enough that it can pick most things, but also small enough that it'll still fit on like a SOIC 8 package. We found that between these two nozzle tips, we have pretty good coverage of different kinds of parts. And if you have a different part that needs a different tip, we include a whole bunch with your kit, so you can always swap it out for a different one. But by default, we recommend putting the N045 on N1, which is your left nozzle, and the N24 on N2, which is your right nozzle. Now, we can't just put these right on the nozzle. We need to tell OpenPnP which nozzle tip is on which nozzle. So what we're going to do is we're going to go into our machine setup section, and under reference head, we're going to select reference nozzle N1, which is going to have our N045. And then we're going to click on the nozzle tips tab here. And you can see that there's an N045, an N08, and N14, all these different nozzle tips that we ship with the machine. We're going to check the loaded checkbox for the N045 row, and this is actually going to cause the machine to jog its head over to the front of the machine to make it a little bit easier for you to mount the nozzle tip. So I'm going to click this, and there it goes. It jogs over, it makes it easy for me to mount it. So I'm going to pop it on. I pre-lubricated my nozzles, so I don't have to do it now, but now's a great time to give it a little bit of extra super lube from your toolkit bag. And OpenPnP gives us an error here. It's not really an error. It's just telling you, hey, do a manual nozzle tip swap. So that's fine. We can hit OK. And then we can see loaded is now checked for the N045, and OpenPnP knows that tip is on N1. Now we're going to go and do the same thing for N2, but just with a different nozzle. So now we're going to go to the nozzle tips, and under N24, we're going to check loaded, and it's going to move to that position as well for us, and we can put our N24 on. It goes on easily. That's great. We're ready to rock. All right, so now what we're going to do is we're going to do our pixels per millimeter calibration for our top camera. We're going to do this using the datum board, which is the little PCB that has our homing Fiducial on it. We added some geometry on there to make it easy to do this calibration. So you can go to your reference head H1, and then we're going to jog to our homing Fiducial position, which is the blue circle with the red brackets around it. Not the blue one. The blue one is the one that takes the current position and saves it in there. We don't want to click that. So I'm going to click this one, and you can see it jogs right to the center of this homing fiducial. I'm going to get rid of my histogram because I don't need it up right now. And if we click on our viewfinder here and we jog around a little bit, we can see we have some of these squares here. You can also scroll in and out on these camera feeds and it will zoom in and out, which is pretty cool. So each one of these squares is 5 millimeters by 5 millimeters. This is what we're going to use to do this calibration. So I'm going to jog as close as I can get, more or less, to the center of one of these squares. That's fine. And then I'm going to click on my LumenPnP capture camera top, which again is under the head in the machine setup tab. And then under the general configuration tab, we're going to scroll all the way down to the bottom, and we can see units per pixel. This is exactly what we want to do. So under object dimensions, I'm going to put in 5 for both X and Y. And then I'm going to click measure. And this is going to bring up a little window on the camera feed that I can grab and drag around. And I'm going to make sure that I line this up as perfectly as I can in the center of this square. That's great. So now that we have that there, the way that you save this is actually by clicking measure again. It's not immediately obvious, but just click the measure button again, and you'll see it'll actually change the values a little bit that are stored in the units per pixel. Now we're going to hit apply to save these settings, and it's going to reestablish communication with the camera, so the feed goes out for a little bit, but then we're all set to go. Now we're going to do the same process for the bottom camera. We're actually going to use the N24 nozzle tip for this because it happens to be 4 millimeters by 4 millimeters. So it's going to be a great thing for us to use to set this number for the bottom camera. First thing we need to do is make sure that we get the N24 nozzle tip hovering over the bottom camera. So what we're going to do is we're going to go to cameras and then LumenPnP capture camera bottom. And then under position, this is the default position that we have for the position of the bottom camera, which is really the center point of the camera's field of view at the correct focal height. So under machine controls, we're going to select nozzle N2, N24. And this means that when we now jog, we're doing it in reference to that nozzle tip. And when we move a nozzle to a position, we're doing it in reference to that nozzle. So now if I click this button here, it's going to jog the N2 to the center point of the bottom camera. So you can see it's off by quite a bit here. This is because we haven't set our bottom camera position, but we're going to do that in a later step. We don't have to worry about it right now. For now, I'm just going to click and I'm going to jog to the center of the nozzle tip and get it centered there. And then I'm going to go to my general configuration tab, and same thing, I'm going to go to my units per pixel and I'm going to enter 4 for each of these, and I'm going to hit measure. Now, LumenPnP has a bug where nothing pops up on this screen now. It doesn't give you the same window it does for the top camera. You actually have to click and drag to bring this up. So if you don't see it in there, that's exactly the reason why. You just have to click and drag on the screen and then the window will pop up. Now what we want to do is we want to have it hug the outside of this bright reflective part of the bottom part of the nozzle. I just want all 4 of these lines to be tangent to the very surface of the tip. Almost got that one. And if you're unsure which circle is the edge, you can always just take a finger and put it up against the very edge, and you can see I'm touching the edge of the nozzle tip here, and you can see where my finger is. This is telling me that it's that edge. It's that side of that circle that I want to be going up against. So this looks great. Now I'm going to click measure again, and it's going to change my values just a little bit, and then I can hit apply to save those changes. And that's it for millimeters per pixel calibration. The next calibration is arguably one of the most important in LumenPnP. This is your nozzle offset calibration. This is telling LumenPnP how far away your nozzle tip is from the center point of the top camera. This is used all across a job. It is super important, and having it be accurate is an incredibly important part of accurate placement. The way that we're going to set this offset is actually using a little wizard that LumenPnP has built in. So first we're going to do is we're going to go to our N1 because we're going to calibrate our left nozzle first, which still has our N045 nozzle tip, the smallest one. And under here there is an offset wizard. So I'm going to click on offset wizard, and they have some instructions about how to go about doing this. They recommend using flour or some kind of putty. You need to make some kind of mark. This is workable, especially with a little bit of blue tack. It can work pretty well. But it's also quite easy to do this calibration just using the homing fiducial itself. So the first thing we want to do is put the nozzle tip directly covering the homing fiducial. So what I'm going to do is I'm going to manually jog the left nozzle, N1, to that position. So I'm going to bump it up to 10 millimeters so we move a little faster, and I'm going to jog it over. When I start to try and jog Z down, nothing happens. This is because under my machine controls, I have the camera selected, and the camera does not have a Z movement that it can do. So I have to make sure I select N1, because that's the one that I want to be jogging down in Z, and then when I do that, I do get a movement on my Z axis. This is a really common point of frustration and confusion, so just make sure that under machine controls you have the right things selected when you're trying to jog or move to a position. And as I'm getting closer, I'm going into smaller and smaller increments, and I want to bring it down so it's just barely above the fiducial itself, just barely touching, if that. Once I have my nozzle tip exactly in this position, I'm going to click the Store Nozzle Mark Position button. And this is going to take my current nozzle tip position, and it's going to save it into these fields here. That's great. The next step is taking the camera and putting it directly over the homing fiducial. So the first thing I'm going to do is, just to be safe, I'm going to jog my Z back up, get it out of the way, just bring it up 30 millimeters or so, and then I'm going to jog my head over and put the camera over the homing fiducial too. Now it's really important that you don't leave this window. If you do, it will erase your nozzle mark position, so you have to jog. You can't go click on the head and just jog to the homing fiducial. You have to manually jog yourself over. So I'm doing that here, and then you can go to the camera and just jog your way up to the center and then do some fine adjustment to get it nice and accurate. And that looks beautiful. Now I'm going to click Calculate Nozzle Offset, and this will very slightly change the nozzle head offsets here in this field. This is doing the math for you automatically, which is really nice for the offset between the camera and the nozzle tip position. And then hit Apply. Very important to still hit Apply here. And there's your nozzle tip cal. If you ever need to nudge it or shift it a little bit manually, you can always just go to the Configuration tab and just adjust these offsets under X and Y. And then we're going to do the same thing for the N2 nozzle as well. So I'm going to go to N2. I'm going to go to my offset wizard, and I'm going to jog my N2 directly on top of the homing fiducial, just like we did for N1. Make sure I select it here so I can jog it down and get it nice and centered. Beautiful. That's great. That's nice in the center. So now I'm going to store my nozzle mark position, and then I'm going to jog my N2 back up out of the way, and then I'm going to jog my camera over so I can capture this new position. Fine adjustment, and calculate nozzle offset when we have it in the right place. And there we go. Now we have our calibration for both nozzle tips in OpenPnP. They're offset from the top camera. The next calibration step is setting our bottom camera position. Now that we have just set our nozzle offsets, we have a really good relationship between true home, which is our homing fiducial position, and our nozzle tip position. So now that we have this freshly calibrated, we're going to use this to set our bottom camera position. The way that we're going to do this is we're going to go into, same thing with our machine setup tab, we're going to go to the bottom camera here, and then under position, we can, just like we did before when we were setting pixels to millimeter offset, we're going to select our N1 here, and we're going to jog the nozzle tip to the camera position. It's actually pretty darn close here. That is not that far off. But now that I have this here, I'm actually going to make it perfect. I'm going to jog it directly in the center, maybe up just a bit. There we go. And then I'm going to store my nozzle tip position here. So I'm going to click this button here, which is going to capture the current nozzle tip position and save it into the field. And this is going to store the current spot where the nozzle tip is to be the bottom camera position. The reason we do this right after the nozzle offset is this depends on the nozzle offset calibration. So there's a lot of dependencies here. We're going to save this position, and we really want to make sure Z is at 31.5. That's what the focus of the camera is set to. After we have this saved in here, we're going to hit Apply, and that's going to save our bottom camera position. And that's it for that. That's a pretty quick one. All right, the next step is nozzle tip calibration. This is a process that OpenPnP goes through with the bottom camera looking at the nozzle tip and deciding and looking at how it moves when it rotates and looking for any runout or change in an XY position as it rotates. And then it actually calibrates out those differences to make your placement much more precise. It's a really, really cool process. Now, before we actually do that calibration, we need to very finely set our exposure for our bottom camera, similar to how we did for the top camera. However, we actually need a different thing to happen with our bottom camera than our top. The main thing our top camera is doing is looking at fiducials, which just needs to find a bright circle in darkness everywhere else. So we want a really stark difference between light and dark, really high contrast. With the bottom camera, we need to both be able to detect the nozzle tip when we're doing runout cal, and then we need to be able to ignore the nozzle tip and only detect the part when we're doing part detection. So in terms of brightness, we want all the background stuff to be 0% brightness. We want the nozzle tip to be at about 50% brightness, and then we want the parts to be at 100% brightness. This is so that when we're looking at the part, we can set our threshold for brightness at about 75 in between the nozzle tip and the part. And when we're setting our threshold for nozzle tip cal, we can set it at 25, so we can still catch that 50% brightness of the nozzle tip. Because of the last cal that we just did, we already have a nozzle tip right over the bottom camera. That's fantastic. I'm going to go to my bottom camera settings here and make sure I'm on the device settings tab, which is where we set our exposure. I'm going to right click on my bottom camera view, and I'm going to show image info, which is going to bring up that same histogram. As I slide the slider, you can see now, for example, in this image, we have a big peak all the way at the bottom, which is all this pure jet black, a big peak at the top, which is all this pure white, and then some more pixel values kind of spread throughout the middle. I don't want any pure white in this image. I want my brightest to be at about 50%. So I'm going to bring this down until my nozzle tip looks about like this. I want it to show up, but I don't want it to have a peak at brightness. I still want to be able to detect it, but I also need to make sure that if there's something brighter on the tip, I'm only detecting that and I can mask out the rest of the nozzle. So this is exactly what it should look like. It should have this type of exposure to it. I'm gonna get rid of show image info, and I'm gonna keep a note of my exposure. Here it's at 687, so I'm gonna remember this. I'm gonna remember this exposure amount so that if I boot my machine up again and OpenPnP doesn't send our config data to the camera, I have 687, I know I can just slide it directly to that and it has all the same exposure settings. We also have photo visuals on our docs page, again, link in the description, and also something to be following along with as you watch these videos. So if you need a good reference of what good exposure looks like for your bottom camera, there's some great images there that can help you get this tuned correctly. In general, we recommend not touching any other camera settings. There are a lot of other settings to tweak. Exposure is really the only one you want to be adjusting for your camera. I highly recommend not touching any of the other sliders for your cameras. Now that we have our exposure set, we're going to test nozzle tip calibration. So because we have our N045 on our left nozzle, we're going to go into our machine setup and we're actually going to go to nozzle tips and we're going to select the N045. And then we're going to go to the calibration tab. And in here we can see status N045 on N1 uncalibrated. So we are just going to hit calibrate and we're going to see what happens. So it's going to rotate it around and you can see here OpenPnP is putting a little green reticle right on top of the black hole in the nozzle tip. This is exactly what we want to see. It gives us kind of this like yellow and red imagery looking for circular symmetry. That's perfect. So now it knows in what way it's offset as it rotates. So I can actually rotate my nozzle tip and it will adjust in the X and Y to account for the fact that there's a little bit of run out, so it still has a really, really accurate centering on the bottom camera, which is pretty cool. And we're gonna also check this for N24 as well. So we're gonna go to this and we're gonna hit calibrate. And sure enough, same thing. It's finding that center point, it's finding the black ring inside of it and centers it really nicely. We want OpenPnP to do this every time we home the machine or change a nozzle tip. So we're going to change the auto recalibration field from manual to nozzle tip change and hit apply. I'm going to do this for both N24 and N05. Nozzle tip change and hit apply. All the other nozzle tips have this by default. We just turn it off for these two specifically to walk through calibration steps. So now we're going to home the machine again, and now it's going to step through all of these calibrations that we've set up for it. It's going to move to the front left corner, do a mechanical homing, then it's going to look for the homing fiducial, and then it's going to do a nozzle tip run out calibration on both N1 and N2. So let's watch that happen. I'm going to hit home. And now it's going to go to the homing fiducial. It finds that no problem. It does a couple scans just to make sure. And then it goes and it finds my N1, my N045. It's doing a run out cal on that. And then it goes and does N2, and we run out cal on that as well. And there it is. The last step in calibration is calibrating your vacuum sensors. The LumenPnP comes equipped with a high-resolution vacuum sensor in each of the pneumatic lines for detecting whether or not a part has been picked. This is a very handy feature. It is not necessary to use the machine. It's very easy to just use the bottom camera to see if a part has been successfully picked. It just saves you just a little bit of time by turning on vacuum part detection. And there's also some other cool features that this can enable the machine to do that we're working on down the road. But for now, it's just an extra layer of reliability, making sure that you picked a part successfully. So in order to calibrate this vacuum sensor value, we're going to go to our nozzle tip. We're going to start with the N045, and I'm just going to jog it here for the camera field of view, just so we're on the same page on which one it is. And then we're going to go to part detection tab here. So we have this by default. Measurement method is absolute. If you want to turn off vacuum sensing for a certain nozzle tip, you can just select none for this dropdown and hit apply, and it will save that settings for you. And it won't try and do a detection to see if there's a part on the nozzle tip with the vacuum sensor. You can still do it with the bottom camera, but you can just turn it off if you'd like. So what we're going to do is we're going to open up our actuators tab in the bottom left. We're going to select VAC1, which is N1's vacuum pump. And when we turn it on, like we did before, we get the pump turning on, and off turns it off as well. If we hit the read button, it'll actually read in a number. This is our reading from the vacuum sensor. So if I read when nothing's on, it's just 0. If I turn it on and then I read it, we get 243. If I have it on and I cover my finger over the tip and I read it, we get 239. So these are these changes in the vacuum sensor value. It doesn't seem like it's a very large difference. This is actually a super high resolution sensor, but OpenPnP does not have the ability to synthesize all this data together for its vacuum sensor reading. So there's a lot more granularity underneath each one of these integers that's coming in this field. So don't worry if there's only a few ticks of resolution. It's still plenty to determine whether or not you have a part on the nozzle tip. So the way we're going to calibrate this is by turning it on and reading it with the air on. Here we have 243 on this sensor. When I cover it, it's 239. So about halfway through that is like 241. That number that's halfway between those two settings of finger covering it and finger not while the pump is on, that's what you want to put into your high value here. This is the threshold that OpenPnP uses to decide if a part was successfully picked. So the default value that comes with the config worked with my sensors, so that's great. I'm going to hit apply just to be sure. And then I'm going to do the same thing with the N24. I'm going to go to my VAC2 now because this is on my second nozzle tip. I'm going to turn it on. I'm going to read it in, I get 251, and I'm going to cover N2, and I get 244. So here I have 245 for my high value. Between 251 and 244, maybe I'll go to 248, give it a little bit more halfway in between. So I'm going to set mine to 248, and then I'm going to hit apply to make sure I save those settings. That is the initial calibration of your LumenPnP. These are all the big important numbers you need to get set correctly to make sure your offsets are correct and you're placing parts well. In the next video in this series, we're going to go through and populate an FTP, which is the sample test board that comes with your machine. This is when we'll actually test our config and make any tweaks and adjustments that we might need to get super accurate placement. And then it's off to populating your own board.